be nice to each other, and let's do some good work. Housekeeping. So if you're in the room, please scan the code before you come up to the microphone. That way we can get the queue managed better. And like I said, we have a very full agenda, so the more efficient we can be, the better. Same for folks that are joining remotely. You're obviously already in the queue. You're already logged in, so please join the queue if you want to ask a question. Here is our agenda. Like I said, it's very full. We have a presentation this time. We're going to try to get back to doing that. Then we have 6 working group drafts, 4 individual drafts, and then as we have time, if we have time, there's a handful of, as time permits, IDs that we want to go over. We have completed WGLC for 6146 BIS. It's going to the ISG for publication as an internet standard. We've issued WGLC for the NAT64 well-known prefix draft that was out, and we've adopted the IPv6 only definition into a working group document. So those are the updates since the last meeting for the working group. And as always, our call for contribution for important works, Brian Carpenter's book. If you're interested in working on that, there's a GitHub repo. It's got pretty good circulation at this point. It's being used as a textbook, I believe, at this upcoming semester in one or 2 universities in the Africa region. So if you're interested in contributing to the IPv6 textbook, it's open source. There's the GitHub repo. Go read it, do some PRs, and we can merge that into the existing text if you're interested. All right. I think we'll get to our first presentation.
I want to take this time to remind all the speakers to, observe the time, especially if you have more than 10 slides.
Yeah, hello. Hope the clicker works. My name is Philip Teasel. I'm with SAP, and today I wanted to talk about how to upgrade a Giant to IPv6. I have spent my last 5 years, 2 years in part-time, 3 years in full-time on managing the technical side of getting SAP IPv6 ready. And when I started in 2021 looking at this issue, the request was more or less, we have growing concern of RFC 1918 space depletion, and we have somewhat of 9,000 Kubernetes clusters in the same RFC 1918 prefix. Let's see whether we should go for IPv6 as a replacement. And at that point in time, SAP had been an early adopter somewhat. We added IPv6 support in the ABAP runtime 2004, and most on-prem products support some sort of IPv6. But as the customer base did not really use IPv6, it was not too well tested. And only a few test beds and Intel infrastructures had remained from the initial boom of enabling IPv6. On the other hand, the acquisitions and cloud businesses were at the point in state where they said mostly no IPv6 because those were built during much more time pressure, and they said, IPv6 is optional, nobody cares about. So, to make this a little bit more difficult, we have a multi-cloud strategy that allows our customers, for at least a bunch of prime products, to choose their infrastructure provider. So that means, for example, if you want to book SAP RISE, you can get it on our own SAP cloud infrastructure, AWS, GCP, Azure, and Alibaba Cloud. And therefore, we have to do the adoption for all these platforms. In addition to local offerings in many countries with other infrastructure partners and sovereign cloud infrastructures for governmental purposes. So how to get this kind of zoo to IPv6? what you need is a strong motivation, and this strong motivation is an IPv6 demand management can't ignore. And in this case, the US governmental mandate for IPv6 only came quite handy. With this very large customer and the clear deadline and more than 200 products affected, you have a large enough risk that even top management cares about IPv6, at least for a while. So for those who have not worked with that mandate so far, a little hint. It requires actions and decisions to enable products being IPv6 only ready. But this is really hard to manage in a big company because you have a lot of parties and people and teams involved in getting IPv6 ready, and they usually don't care about networking protocols. And to make it even worse, the regulation is phrased as an indirect regulation. So it does not say companies have to do IPv6. It says everything the US government buys needs to support IPv6 and is IPv6 only ready, which does not meet any usual compliance framework. And the usual way of taking this in would be through someone at these agencies who has no idea about IPv6 has to put this in their call for tenders, and some salespeople who usually have no idea of IPv6 have to take this in as a requirement. And as a central program, we try to bridge that and directly transfer the requirements of the US IPv6 only mandate into internal standardization to make sure that we have actually a document that's easy to understand for our developers. And the key question for this is, at which vantage point is IPv6 really required? So looking at the NIST profiles, SP 500, 267A, this one is only partially helpful because it's not written as a standard developers usually follow. It's written as a template for call for tenders. And so what we did is we defined an internal product standard saying the whole portfolio supports IPv6 without functional regressions, irrespectively whether the custom environment is IPv4 only, dual stack, or IPv6 only. And that means customer can access all SaaS applications. Integrations work seamlessly with any customer endpoint, and on-premise products work in any IP-based network environment. What's not on the slide is we explicitly rule out that we won't require anyone to use NAT64. So an IPv6 only, or how we now have this strict IPv6 only customer should be able to work with us without any modifications. So, but before you can test the actual products, you have a lot of internal infrastructure you have to upgrade. Developers need IPv6 in their access networks and offices, and development and test landscapes need IPv6 support. And while I had a lot of fear in the beginning that this could be an issue, in the end, talking to our office network people said, oh, we have to add IPv6 support. And they said, oh, we can't do this. We're in the middle of, or we're planning a rollover of our whole hardware stack. So I asked them, so could you just fold that into the hardware rollover if you're replacing anything anyway? And they said, oh, we have to think about that. And a week later, they came back, oh, yes, we do it. And this is also one of the biggest recommendations I can give to anyone who wants to deploy IPv6 at a large corporation. Don't try an ambitious timeline. Try to look where are processes where a lot of stuff is touched and try to fold in IPv6 rollout at exactly these places. The other important part is you have to get it into runtimes and runtime environments. And we have a lot of these. We have the ABAP environment, which is most famous for the applications. We have Cloud Foundry as a container runtime, and we have Kubernetes, our own Garden, our own Kubernetes-based runtime. And for all these, most of these, or some of these is open source backed, and we made sure that also these get updated. And the lesson learned there is, so IPv6 is pretty mature across most language runtimes. But there's especially gaps in documentation. So if you look at the Python documentation, you find that most examples are v4 only, and you have to dig a little bit to understand how to get them v6 ready. There are surprising defaults, like Java still prefers IPv4 over IPv6. And the state of happy apples heavily varies. In the end, what we found out is most code just worked fine when we actually updated the runtime environment and had a little bit of documentation. So we have only a few products that actually found bugs. Most just tested and said, "Oh, we're done." That V6 support heavily differs by the different cloud providers, and that's really a pain, because you get, if you're doing multi-cloud, that's not only multi-pane, but it becomes even more painful if you have to account for the different IPv6 environments. And finally, fixing IPv6 issues in open source is key, but especially in the Kubernetes ecosystem, there are surprisingly many gaps, and upstreaming changes is usually much more difficult than just fixing them and build the PRs. So in the end, my takeaway is getting IPv6 ready is not a technical problem. It's usually an organizational challenge, and you have to be good with people to roll out IPv6, not with bytes. So where's SAP today? We delivered IPv6 to the federal government customers, and I think we are, except a few regressions, really done with that. We have a few front-runner products that support IPv6 also to regular customers. That's SAP Concur, and that's the BDP connectivity and destination services, which are, more or less the crown jewels where most of the global business would break down if these were down. We now offer IPv6 as an optional features for the SAP Business Suite in the RISE offering, and we added Happy Eyeball support to our ABBA platform. And we're currently looking into how to get this to other public cloud customers, especially for BTP and HANA Cloud. And with this, I have no time to take questions, I guess.
If there's any questions from this, we can take it to the list.
Excellent control of time. Jordi, you are next.
I can't see the queue. Can you make sure?
Okay, so this one is going to be very quick. This document was adopted by the working group, I think about 2 or 3 months ago, after the last meeting. Basically, in short, the document is looking at different aspects about recommendations for point-to-point links, and it's more or less following what we already have in RIPE as V6OPS 690. Okay, so we answer different questions regarding the size of the point-to-point links, how we number them, etc., etc. What have been the main 2 changes? I think in the last 2 versions, that's why I used 2 colors. We incorporated some comments about PPOE, IPOE, clarifications about persistency versus privacy, address reputation. We removed uppercase normative language and relaxed the BCP summary. There are also some recommendations for publishing prefix lengths according to one of the documents in OPS AWG. There is also a change in the title. It was initially end users, now is end sites, because actually we're talking about end sites more than end users. And then some additional information about prefix persistency and mitigation reference to temporary address extensions. So what is the situation? Well, still open for questions. Any new inputs? I am not sure if people has read the latest version. I really think it's almost ready for last call, but I really think we need some new people or people that already has read previous versions to provide some new inputs. And I think that's it. So this one was quick. How many people has read the last version? A few? So new inputs. If not, we go back to the list, maybe asking for specific questions or...
Any questions on this one? I would encourage folks to give it a read and do some more discussion on the list.
Yeah, in general, we need more reviewers, and sometimes in a working group last call, we don't even get 5 reviewers. So please.
All right.
So we save it some time.
Okay. So
Please read it and comment.
Next one. Okay. This document is a document that we started a long time ago. It was already adopted as working group item, but the solution was not the easier one, okay? So basically the problem is that the same that when you have CDNs and caches in IPv4 with CGNAT, there are optimizations, so the traffic don't necessarily go through the CGNAT all the time, okay? So here, when we deploy either MAPT or 464XLAT, we have a similar situation. We have, for example, all IPTVs that are IPv4 only, or even set-top boxes or whatever. And if we just do the regular deployment of MAPT or 464XLAT, the traffic will be translated in the CPE to IPv6, from IPv4 to IPv6, and then traverse the network and go again translated to IPv4. And this is ridiculous because the CDN or the caches are already dual stack, okay? Let me show the picture. So this is a typical deployment. So normally the traffic, if the origin host is IPv6, will go like that. But if we have an IPv4 only host like an IPv4 only IPTV, it will get 2 translations. So it don't make too much sense because this is overloading in necessary the NAT64 box, okay? So what we want to do is something similar to this because we already get a stateless translation at the CPE, well, typically a stateless translation from IPv4 to IPv6. We want to keep using the resulting synthesized IPv4 address, okay? So originally, we were studying 3 approaches. The first approach was DNS routing based. And in the previous versions of the document, we don't have the 4A record, okay? We discussed that with CDN operators, and they told us they really don't want to do this. And I am guessing that part of the reason they didn't want to do this is because they were not able to use, at least not according to standard, 1918 IPv4 addresses in the NAT64. But now this is changing. So because this is changing, it looks like this approach can be much better than the other ones. So this will be the result. We have a direct path without passing through the NAT64, okay? Now, the other 2 approaches were, and I am not going to go into the details, were using a CLAT DNS proxy explicit address mapping table. And the other approach was, if this works, a CLAT provider explicit address mapping table. But these 2 approaches were really complex, and it means modifying the CPE, which the approach number 1, we don't need to change anything. We just need the CDN operators to deploy Quad A records using, if they are using in that deployment the well-known prefix, using the 1918 addresses. Okay, so the question here, and it's almost done, is, okay, I just mentioned this. The question here is, if we have CDN or catch operators looking at this document, if they can confirm if they will agree with this approach. Okay, so that's the basic question we need to answer. Because the obvious recommendation now is let's do approach number 1 instead of approach number 2 that we were recommending before. Of course, this depends on passing the well-known prefix 1918 document that I think is being presented later as well, or not anymore. There was a new version yesterday, I think, Warren, for your document. You sent the last version yesterday, so that will go into the last call now, I guess. Yeah. Okay, so it depends on that, but I think it should not be a problem. Now, I have one open question here. Assuming the operators agree that this is a good approach, I mean CDN operators or cache operators, I think we should split the document actually in 2 documents. I think we should split the document in one informational document, which is almost what we have today, and then a BCP for approach number 1. This is an open question that I am asking to the working group, but again, we still depend on at least some CDN and cache operators telling us, yes, we are happy to do that. They are actually doing for CGN, which is not for 4.4, so it should not be a problem. And I think that's it.
All right, got a couple questions.
Hey, Jody, first thing, I really didn't get the part with Quad A records, because you are talking about IPv4 only device traversing the CLOT device in your CPE. So where exactly is the need for any Quad A record? It's only the routing thing, isn't it?
Yeah, you're right. We don't even need the Quad A record. Yeah, that's something I put in the slides. I am not sure if I put that in the document, but it's not even needed. Well, maybe they prefer to do that for clarity, or I don't know. But yeah, probably it's not even needed. I need to think about that.
So the other thing, for the sake of that, I will just shut it down. I feel like the option number 3 is actually the most usable part in the long term. I think it will be nice if there will be some sort of provisioning protocol, be it DHCP V6 option or some HTTP endpoint, whatever, that would make the CPE download the explicit address mapping. Because if you are running a CDN node in your network as ISP, you know exactly which endpoints you should map to which endpoint. So you should just provision it to CPEs and be done with it.
Well, I was thinking it's better the approach too, but I recall we had lots of discussions with CDN operators, and they said that not. And in any case, it needs modifying the CPEs. Yeah. And you know what it means, modifying a CPE? No way.
Okay.
Right? We don't get firmware updates for CPEs for things like that. The CPE vendors, most of the time, they don't care.
Andy Yurshenko. So I happen to maintain a kernel module that might be used in at least some of the CPEs to do the translation. And 2 points. So in that kernel module already can install the static mapping entries. And about the provisioning, as far as I remember, back in the day in softwares, there was tons of DHCP options already defined. And the FMR, as far as I remember in MapT, or it was more generically defined as S46 rule or something like that, that's already there. So if the support is lacking, that's the standards non-conformance, which is a different thing than implementing something new. So maybe it's worth looking at that and just bring that to conformance.
Yeah, the problem is not a standard part. The problem is deployment or firmware updates to CPEs, you know.
Yeah,
yeah.
But it's maybe there already.
Yeah.
So it's worth just testing and seeing whether it's there. It might be.
Jen?
Despite company on my batch, I do not operate CDNs. I have no idea if anyone actually going to do that. So I was curious if you tried in practice any of this.
Not this approach, because we discovered in previous conversations that CDNs were not happy with that. But now that we can use, or we will be able to use private IPv4 addresses with the well-known prefix, things change. And the fact is that CDNs are doing this with private addresses in IPv4.
So if I understand correctly, the first option is just your CLAT just translates, and as long as your server has 64FF9B V4 address configured on its interface, it would just work, right? If you route it correctly. The question is, yeah, if you control the servers, yeah, it might work. I'm not sure, like, again, it would be really nice to see some proof of concept, at least deployment of option number 1, right?
Eric?
Yeah, I'm sorry. I'm very confused about how you think this can possibly work. Can you go back to one of the architecture slides?
Which one?
Just about any of them. I think I just need to see this. Hey, yeah, so that's fine. Yeah, this one right here. So if I understand this correctly, the CE, you want the CE to take the public v4 address of the dual-cast service and and use the public quad A of the dual stack service, not the DNS64 address?
Actually, if the CDN is using private IPv4 addresses, the synthesis of the CLAT will create a well-known prefix with the private address.
Oh, this is only for CDNs that are within the operators network?
The CDNs are already doing that with private addresses for IPv4. So we don't need to do anything.
So the IPv6 internet here on your diagram is not, I see. That's
it's not passing through internet. It's the direct connection in the ISP infrastructure.
I see. Because as far as I was concerned, I cannot tell how the CE is supposed to know that the IPv4 smart TV didn't use DNS over HTTPS to look up a service that truly was v4 only. And then, but I think I see what you're doing. You're not using the public quad A of the DNS of the dual stack service. So that makes a little more sense. Thank you.
Okay.
All right, we're over time now, so I think there's someone else in the queue, but I think we're going to need to take it to the list.
And the last one, this was adopted as working group item in the last few weeks. So we published already the first version as working group item. The problem, again, not repeating, is clear definitions of IPv4 only, IPv6 only, etc. Okay, the idea is not to define all the possibilities because that's impossible. We already learned the lessons in previous versions across the number of years working on this, but instead going to the basic, very, very basic definitions, and then making sure that we state the scope. Okay, so if we talk about access network or core network or BGP or whatever, we always need to specify the scope. An example of IPv6 only is here in the slides. I am not going to read it. And what have been the main changes? Well, there is an overall text review, even some reordering of some text. Additional scope qualification. Somebody suggested that we should specify also if it's data control plane or bot. API scope clarification. The idea here is not expected to be IPv6 only by now, so recommended to be dual stack. And I added a lot of diagrams with short of explanation of each one. And I think that's it. So I didn't got any new responses in the list since we published this version. So again, as in the first document I presented today, I think it's almost ready for last call, but again, I really think we need some new review from the working group. And that's it. How many people has read the last version? None, or I don't see any hands, so really need someone else to read that. Thank you.
So I would also encourage folks to read this. I have yet to read the newest version, but with no hats, I think this is important, and I'm glad you're working on it. I would also encourage other folks to take a look. It's a hard problem that I've run into in working on this kind of thing, and so having something to reference would have been very, very nice.
Untitled, I read this and I looked at the examples. One thing I have an issue with is that there's an example of IPv6 mostly network that has two hosts. And both hosts are, according to the definition of this terminology, called dual stack, even though one is using IPv6 only, generating only IPv6 packets and having CLAT inside of it, while the other is generating native v4 and v6 packets. So I think there should be some way how to discriminate, because there are two different modes of operations, and if we both call them dual stack, we are just losing this precision for.
I think I thought about that, and the problem here is that initially the host is dual stack, and then it becomes working as IPv6 only. So it's a special case, but we can see if we can improve that.
So maybe like improve a scope saying that applications are dual stack because they see v4 and v6 connectivity, but the network interface is v6 only.
Well, actually, because we are talking about the scope, you can say that according to the actual document.
Okay.
You just can extend the scoping, let's say, I am not sure if in English is correct, but you can extend the scoping as much as you want to make it very, very precise.
Mm-hmm. Thank you.
Tim.
Hi, Tim Chan. You just led into my question nicely. Can you use a word other than scope? Because I think people are going from V4 to V6.
Okay.
Don't really understand. Scope is a new thing to them.
I think I started with context. I think Shipeng suggested the scope, but
yeah, don't use that, because then.
Okay, so which one you suggest, or you want to think about
something
that?
else, maybe context. I don't know. I have to think about
context. I was using context, but
yeah, don't use.
Well, we can discuss later on. Yeah, I mean, I am fine either way. I am not native English, so I am not sure which one is the best. That's it.
All right.
Yep. Thank you.
All right.
Hey, if you have heard my previous presentation, you now see one of the outcomes from that. Because as I consulted a lot of people in doing IPv6 testing, we now have at least a body of ideas on how it is. So if you haven't read the draft yet, it basically is targeted to be a BCP on how to test applications for IPv6 only readiness. So the target is really, it should work IPv6 only. For classic applications, as well as software as a service or cloud applications, it lays out basic connectivity scenarios you should test, or at least consider for testing, how to test intermediaries, name resolution, how to test for partially broken connectivity, common test strategies, and common sources of IPv6 related failures and misbehavior. And after having read this, a developer should have an idea what testing for IPv6 only readiness of an application means. So since the last, the draft is relatively young. Last year in Montreal, it got presented, got adopted in December. We have now a 0.1 version after the working group feedback. And as we don't, in this, we did the following changes, like section on testing, we added a section on testing name resolution issues. We extended the text on testing with partially broken connectivity. Some people suggested also doing a little bit more on testing without IPv4 loopback addresses, which is
difficult on Linux, but you get into similar scenarios based on some socket on syscontrols. Considerations for addresses as data and change the term true IPv6 only according to the nomenclature of the last document presented by Jordi to IPv6 only strict. So we did not get too much feedback on the mailing list, but and therefore I hope we could get this document perhaps towards last call this year. So one of the so two feedbacks I got was about the general scope. Matt suggested also to talk about benchmarking and performance aspects, and I would be happy to take input on that one, whether you think it's necessary, whether it's a good idea to just focus the document only on the functional testing aspects. We got some feedback that there should be some consideration on customer support. Not sure how that fits in, but I'm happy to take suggestions how to do that. And there are two other things. So do we need more on the common IPv6 testing issues? So Frank Martin suggested having some text about forgetting to listen on IPv6. I already have a PR for that one. And with that, we can also look about testing against IPv6 only listen and syscontrol options. And the other question is whether we want to have more deployment considerations, but I think this is better. Frank's draft about data center deployments is the better place for these kind of considerations. So with that, I had asked the working group a few questions. I'm happy to take input on that. And finally, I would love to see whether you think we should try to get it towards the working group last call soon.
Tim Winters, QA Cafe. So for performance, what are you guys thinking? That was my only question. Are you actually what are you measuring for performance? Like throughput? What are we talking here?
So we did not measure performance at all because we just focused on functional testing.
Yep.
And my experience is that performance, I've never seen a case where an application implementation really screwed up performance when getting enabled with IPv6. That happens a lot in the deployment of an infrastructure or landscape, but not so much in the application itself.
Okay, that's what I was curious of. My second comment here is about control traffic and management traffic. What we've been seeing a lot lately with V6 only networks is only one of the two will work. Only one of the two will work. And I looked for a mention of it, but I didn't see any mention of just be careful that your control and the control traffic for an application goes on a different path than the data path. And so sometimes people make very poor choices that you can control the app, but it doesn't actually do the thing you want it to do over V6. I looked for it, I couldn't find it anywhere. You guys have like user interface stuff, that's all great, but might be something to talk about. It seems to be something that people are missing on the regular at the moment.
I think it's, I understand where you're coming from and how to discuss that.
Yeah, I mean, I'll leave that to you guys. It's just, this is really just a food for thought thing. There might be something you can say that's a little bit more strict because that's the common problem I've been encountering.
Yeah, I totally get that.
Hello, good morning. Savio from Nick.br. As I told you a couple times, this draft is 100% necessary. As someone who used it to teach for developers and also who is struggling with companies who are developing software, this is the kind of content that they need to care about because IPv6 is a non-functional requirement for internet connected applications. So this is a very important draft. By the way, I sent in the list a tool that I'm trying to develop to make it easier to translate what's in this draft for developers and teams, and also system administrators who are trying to test one application if they are IPv6 capable or not. If you are interested, just check there the thread from the last update in the draft. I didn't see before these considerations on customer support. I can try to get something maybe included in the draft, gather some maybe troubleshooting and something for applications. And that's it. Thank you very much.
Hi, Tim Chan. The front microphone is in the Scone working group, and the rear microphone QR code is in V6OPS. Just very confusing. Well, I put my hand up before. It was getting. I thought Nick was putting my hand down, but it was the Scone chairs were putting my hand down, because I wasn't. Anyway, so what was the question? Yeah, so I think this is really good. I think one of the ways you could maybe split it a bit more, looking from the point of view of what we're trying to do in terms of getting software development better with better V6 support, is to maybe split the focus a bit into what those in the IT department setting up an infrastructure for the application testing might do, and what the people doing the application testing might do. Because you've got some bits in there that talk about, making sure the CLAT is disabled for V6 only, that sort of thing. So I think maybe there's something along those lines you could look at. The other thing, as you said in your first talk, is the variability. If you're trying to test in various cloud platforms or Kubernetes, there are issues. And I think, having those documented well would be good. I think some of those are in here. But I think overall, it's a really nice document, and we should certainly take it forward. It's just maybe there are some ways of reorganizing it that might help. And yes, the 6724, I know from bitter experience, there are some nodes that do 3484, 6724. Some have done some of the draft 6024 update stuff, and some do completely their own thing. So that's a minefield, as I'm sure Tim too behind me would agree.
Yeah, I think 6724 is really something that surprises a lot of application developers in one or the other way. You need a lot of insights and a lot of experimentations to, in the end, at least in my experience, always come to the conclusion, yes, it makes sense how it was set up in 6724. At least the stuff that's surprising for IPv6 application testing. But it takes a while until you get to that point.
Yeah. And the other final thing I was going to say, I was thrown out by the Scone thing. The final thing I was going to say was there was a really nice project done by Aaron 2 or 3 years ago, a sort of a V6 only test box as a service. And that was very interesting. I think Nick's aware of that, but it was only available to people in the Aaron region. We couldn't get hold of it, for example. But that sort of thing might be a useful thing to develop and make available more globally, I think.
All right, I put a poll up real quick.
Alex, it's one question. There are some cases when you install an application in a dual stack environment, and then you want to reconfigure the application to a single stack, like V6 only environment. And in some cases, the applications fail to capture the change. And for example, they may have some IP address configured in the config. It might be interesting to see a test scenario where you start with dual stack environment and switch to V6 only strict in the document. Otherwise, the document is great.
Interesting question. But the question is, so in bigger environment, how common is that? So I would usually envision that when you make such a drastic change, we at least restart the machine and then would also start with a fresh config.
You do, but then still the application can have this v4 only context saved somewhere. Just food for thought. Thank you.
All right, thanks. Timer? Oh, yes.
Hello, I'm Andre, and I would like to talk about filtering address records in stub resolvers, which is a draft that I wrote here. It's basically this very simple thing that many operating systems or applications are not doing query queries if they think they don't have IPv6 connectivity. It's also written in some RFCs like the Happy Eyeballs 2.0 or so. The problem is, what is actually IPv6 connectivity? And apparently different platforms have different opinions. Some things like, I have default IPv6 connectivity if I have default route on default interface, but not on some software like VPN. Some platforms consider default route on VPN also as IPv6 connectivity, but that's still not enough because there are also split VPNs. You might have just a few IPv6 prefixes delivered via VPN on your computer, but the rest of your computer can be IPv4 only. So is this IPv6 connectivity? And in my opinion, yes, it is. So basically the purpose of this draft is that simple. Like if your computer can reach any, at least single IPv6 address that can possibly appear in DNS, then your computer should do query queries. Because otherwise you cannot really use IPv6 only networks, IPv6 only VPNs, because, well, you will never discover them because of the computers not doing the query queries. So what is new in this version is explanation why actually it is beneficial to do this filtering, not to do query queries at some point in time. The biggest issue is, of course, that DNS is UDP-based protocol, and of course, the amount of brokenness of things on the internet is always bigger than you can even imagine. So not only that networks are suffering from packet loss, which is impacting UDP-based protocols a lot, but there are also DNS recursive resolvers that drop queries to unknown query type for them, like quad A. So if you ask quad A and the response of the DNS resolver is silent, and you are doing proper ordering and dual stack, you have to wait until you time out before you can go further, and this will be user notifiable delay. So that is why like not doing query queries if you are sure that you are not on the network that supports V6 is beneficial for the user. However, there are standards like Happy Eyeballs, at least 2.0, 3.0 now in development, that do asynchronous processing, which will sort of eliminate these user perceived problems. Also, there is this draft about multi-queue types where you can do one DNS transaction asking for multiple query types. And of course, in that case, you can always ask for everything because it should not matter. So in my case, the draft is going in a positive way. So it's basically telling how you should do the filtering properly. It's not doing it only for quad A records, but also for A records. Wrong terminology, sorry about that. Pure IPv6 only network is actually IPv6 only strict. And deals with 464X slot and NAT64. And also proposes two algorithms how to figure out whether you have route to IPv6 or not, either looking into routing table or looking into IP addresses, and stressing mostly that not just default route, not just default interface should be considered for the purpose of this filtering. The important thing to say here is that most of the stuff here is also part of the Happy Eyeballs 3.0, at least the changes there for accommodating V6 only networks. So this is sort of like supplementary draft only for systems where Happy Eyeballs 3.0 would be super complex because it's mostly dealing about SVCB records for encrypted client hello and things like that. But this filtering of quad A queries is something that hits you even if you just want to SSH to an IPv6 only network, IPv6 only server that is reachable via VPN, and it just doesn't work. So I'm trying to keep this thing small and focused. As I said, Happy Eyeballs is solving the same thing. It definitely needs more input. Yeah, last call, probably not yet, but yeah, eventually I would not like to, put everything but the kitchen sink inside, but just keep it on this level.
Janinkova, first of all, full disclosure, I have not read the last version of your draft, but based on the extensive discussion we had in Happy, My understanding is part of the problem is that in general, in most of the cases, you do not want to resolve through one interface and send traffic through another, right? But in some cases, you might need two. And that's the reason that the most recent version of Happy Draft defines, like, uses the term PVD, right? Because I'm a bit concerned when you say any route on any interface, because I'm not sure what's going to happen, like with mobile network connection and Wi-Fi and all that kind of stuff. So I think maybe what would be beneficial in general for the industry if we start like doing more work in the PVD area and define like how this multi-homed host with multiple interfaces should actually behave, right? Because if I'm right, you're trying to solve the VPN problem mostly, right? And maybe you need to explicitly talk about VPN and explain like how VPN needs to be done. I'm not even sure it should be done in V6OPS, right? Because if you generalize too much, I'm afraid it might be unexpected side effects, right? And again, I think we need to make sure whatever your draft proposes is consistent with Happy Eyeballs, right? Otherwise, we're going to see some unexpected side effects.
It is consistent, yeah, in that sense, it's okay. But yes, like the provisioning domain thing is, yeah, exactly the part of complexity that I would prefer to avoid, but maybe it's unavoidable.
So Nick Baraglio, ESNet, no hat. The VPN problem is very real. I have had complaints of that as recently as Wednesday. So I think it would be a good idea to maybe deal with those complexities within, the draft. And I also, full disclosure, I have not read the last version of it either, or if I did, it was long enough ago that I don't remember the details. But I do think that that is a legitimate problem that does need to be solved, and I think there's some possibility for that here. So,
thank you.
Hi, Marwan Fayed, Cloudflare, not on the operations side. In their first or second slide, it's just some confusion that I want to sort out. You said if the address is in the DNS, and in principle, I love this idea. I haven't read the draft, but that part confuses me. Why should it? You don't know if it's in the DNS until you do the query. I would think it's just anything that's publicly routable.
Yeah, I know what you mean. If it is address space that can appear in the DNS.
If it can appear.
Well,
right,
because there's basically the thing, because if you have IPv6 capable hosts, you always have link local addresses on all interfaces. And they shouldn't appear in DNS, so you should ignore them.
Yes, no, it's the can appear, I think, that I missed.
But basically the point is, even if it's this ULA prefix, that's something that can appear in global DNS, and you should, if you just see ULA addresses on your interfaces, I think your computer still should do query queries.
Understood, thank you.
So anecdotally, the problem that I just described that was reported again Wednesday, we have a sort of an ugly hack that essentially when the VPN interface comes up, it runs a script that it just populates a ULA address onto that interface, which seems to solve some of these problems. It's fairly ugly, but it does work.
Mm-hmm. Yeah, the VPNs are really tricky part in this sense, because there's like thousands of different setups, including like where the DNS is resolved. Is it the global DNS? Is it the DNS over VPN? And is it full tunnel, split tunnel? So yeah, I don't think there would be ever documenting all possible ways how DNS can fail, VPN can fail.
Any more questions? Thank you.
Thank you.
Okay, I'm here to talk about 7084 IPv6 routers on behalf of my authors, Jordi, Gabor, and Ben. Okay, so there's a new version of this. I think last IETF I got up here and said we were almost ready for working group last call. We added some stuff. So some of it we got were comments on the list, and then we got a couple of pieces of feedback during the last IETF. So a couple of things we did. One of them was administrative, RFC 9818, which is doing PD. On the LAN side, we obsoleted that. It seems like a new one. Why would we obsolete it? Basically, we took all the text, and it now is in 7084 to give them one place to look instead of two. I think Ted pointed out V6 hosts are capable of Slack. Should be. This was one of those, this was in the original 6024, it just never got updated, so we fixed that. L21 is RA guard. We had some comments about why it was off by default, and so we added some text to say, hey, snack and unmanaged routers. There's a bunch of scenarios you do not want RA guard on for by default. So we did all those changes. This was a change we made, be a little more explicit about ULAs. So the original text I have is up there, the old one. It was pretty simplistic. We gave a little bit more on the should side of this to explain to people why it's a should and how you should go off and do this. Okay, this one. My fault on this one. I wrote this up, but we got some emails about this, about supporting DOE, and we've seen it in some home gateways, definitely. And so we thought, yeah, we'll add it. And I forgot to put the words in the DNS proxy functionality. So there's a lot of confusion around this. My fault. This one's on me. So I fixed it. It now says IPv6 routers should implement the DNS proxy functionality of DOE and may support DOT. That's basically what we've been seeing. There are some routers out there that do DOT, but DOH is way more popular. So I think that addressed a bunch of the comments on list. I'm hoping. If anyone has any comments on that, please come on up. Okay, I hate these flags. So the MNO flag. There is a new WAA12 that I'm getting rid of that has the text below. I think this all belongs in one place, just to be clear. What we've been starting to see is home gateways who get an M flag set to 1, start doing DHCP, and then there's a flap for whatever reason, whether it's a second router or a confusion, and the M flag changes to 0 and it dumps its entire DHCP and then restarts the entire process over again, over and over and over. Please don't do that. So I added text. This text actually I basically stole from the original neighbor discovery that says don't do this, and I made some minor modifications to it and said, hey, if a flag changes, don't dump your DHCP table. If you got one, just keep DHCP on. In particular with home gateways, PD, you basically need PD to do anything. So turning off DHCP is a really bad idea. I did talk to some operators who still want the ability to kill DHCP, and so that's why I didn't say just ignore the MNO flags. Boy, did I want to, but I've talked to a couple of people that said don't do that, so I didn't. So that's the situation there. I don't think this is a major change. It's just we should get this fix in there. So the battery's dead, or it doesn't like me anymore, or both. Both could be true. All right, so this is one that came out of 3901 biz. So those who haven't been watching, DNS has been going through a little bit of an update. We added 2 new requirements. I think we got these from comments. I think there was a presentation about RIPE about some of this. So we tried to cover both of those. If implementing DNS proxy, the CE router must support IPv6 when resolving or forwarding DNS traffic. So what happens here is some gateways have made some really interesting choices when they proxy, and on the LAN side, they're using V6, and on the WAN side, they switch it to V4. That's questionable, so we suggested they not do that and use V6 whenever possible. This is one of those weird oddities that, yes, I've seen it. It's a little more prevalent than I would like, so that's where it's there. The other one is we added R5 and R6 are about the size. This is about fragmentation on DNS. You can go read those individual ones. I didn't call them out directly, but this is saying, hey, don't try to avoid fragmenting DNS whenever possible. And so this is suggesting that the CE routers, again, when performing queries, does all the right things to avoid fragmentation in DNS. We had a couple reference updates. This came up in 6-man when we did node requirements. So for this, node requirements points to this doc, that doc points to this doc. So we're going to update them both and have them both point to the biz versions. They're both very close to going to working group last call, which is nice. So we're going to do that everywhere. And then the other one we missed, I don't know what I was doing. 9915 is DHCP v6. We should, as a standard, there are no major changes, but we should always point to 9915. So we're going to make that change. And I think that's everything I have on the list. We're ready for working group last call this time. We're going to put out any comments from this one, make any changes, and then we're ready to go to working group last call with this doc. Really, this time, I'm not joking. Okay.
Hello, Stefan de Bink, SIDN. Can you go back one slide?
I can't, sorry, lost control.
So there was the mention of the proxy must support IPv6, and I was wondering if that should be a capital must.
Yes, yes it should.
Okay.
Agreed.
Thank you.
Yeah, I wrote this up. I haven't put it in the actual doc. Thank you. I will make sure that that's a capital must. Absolutely.
Hi, Tim Chown. This isn't the multicast question you're expecting. It's a more general one about multicast.
Okay.
If we see opportunistic use of multicast from media over quick relays, which might happen, should we be thinking about multicast requirements in here? At the moment, there's one paragraph about multicast that says something like the CPE may act as an MLDB2 proxy, it may be a multicast zone boundary, and that's it. And those are lowercase mays.
Yet they're 100%
there
lowercase mays.
It also says in the introductory text about being a ULA boundary effectively as well. And then there are musts about that.
Yeah.
So is that something that maybe multicast will never happen in V6 residential networks? Or is that something we should put in here? Or is that something that should be a separate document that could maybe include other scenarios for opportunistic SSM from mock relays that might go into campuses that's more interesting to me?
Yeah.
How should we handle this? I think we need to write it down somewhere.
Yeah, for, 7084 has always been very, very quiet about MLD. And in this case, yeah, MLD, I'll avoid the IGMP problem. But for multicast in V6, operators traditionally don't want it to cross any boundaries, right? They want it to stay in either the home net or on their side, or they want to be totally in charge of it, which is why the text is very, very, very loose. I'm not sure that's the place to do this, mostly because this is for customer edge routers. I think it's a different conversation when you're talking proliferating into the network, but at the edge boundary, I think we're in a weird spot where, yeah, and this comes up, right? I mean, there are definitely operators who have multicast applications, the biggest one being IPTV and making sure that certain things work the way that they want. But my experience with that is it's not standard, and they want it to work the way that they want, not standardized yet. So I don't think we're there yet. I think it's a little late in this process to do it, but it's an interesting thought. I'm not, support for multicast and home gateways is it's not great. So that's something that I think we could work on. And then the proxy functionality is very different.
Okay, yeah, I mean, my interest in that is with sort of campus type networks.
Yeah, I can see that.
I'll be looking at that, but yeah, just curious.
Yeah.
The fix to the DOE requirement text, should that say should support DNS proxy with DOE, or should it say if DNS proxy is implemented, it should support DOE?
Oh boy, that's a good question. I think if they do DNS proxy, well, which one do you want it to be? I'm open to suggestions.
Well, it's if it's doing DNS DNS proxy. I think as written, it's kind of sort of implies that you should be doing DNS proxy and it should have DOE.
Okay. Gotcha. We'll fix that. Cool. Okay. I think I'm good. I'm going to slowly back away. Thanks, everybody.
Turn it on. There you go. All right. Thank you.
So I'm next to talk about enhanced dual stack. The purpose is to help enterprise deploy IPv6. And here's why. I feel that the current dual stack does not work as well as it could or it should. Ideally, dual stack should work like this. Because before you deploy it, IPv4 already working there. And therefore, after you deploy dual stack, if IPv6 work, then it's used. If IPv6 does not work, you should continue to use IPv4. And the user shouldn't perceive any performance disturbance. And if this is the way, then IPv6 deployment will become fairly low risk and therefore easy. But it's not the case because currently a dual stack host select IPv6 and IPv4 based on the 6724 rules. Although the rules work most of the time, sometimes when IPv6 doesn't work, it may still be preferred. And as a result, the user may experience some service disturbance. And for the network deployer, for the IPv6 deployer, in order to avoid this from happening, he will have to do a lot of upfront validation. And then also face the judgment moment when he switch on IPv6. And therefore, this is a little risky. Because of that, many small and medium enterprise are reluctant to deploy IPv6 because they feel that they have to do a lot of work. It's still risky, but they don't really need that many address. So they don't have the motivation. And this is what enhanced dual stack objective is to bring dual stack to this like ideal operating state, meaning that when you deploy it, if IPv6 works, it's used. Otherwise, you continue to use IPv4, and therefore, it's relatively easy to start, and also to provide data when IPv6 is not selected. Why? So that the deployer can go to identify the problem and fix the problem and move on. We believe that this is important. Otherwise, it will take a long time for small and medium enterprise to adopt IPv6. So how are we going to achieve this? We propose 3 enhancements to dual stack. And the first one is being actually V6OPS or platform implementation profile. Happy Eyeball has brought the traditional dual stack a big step towards enhanced dual stack. But we believe that something can still be added. One is OS implementation profile, because currently Happy Eyeball doesn't specify the implementation location, and therefore you can do it. You can implement it at the application, or you can implement it at the OS. But if you implement it at the application, then other application does not benefit from it. So if we can put it in the OS or in the platform, then more application can benefit from it. This is the purpose. Because there are many existing applications, they don't use the Happy Eyeball API. And therefore, they cannot benefit from Happy Eyeball. For example, they continue to use the get address info connect function. And therefore, the second enhancement is that we propose some improvement to get address info and the connect function. Basically, the connect function will provide the performance stats for the get address info to consider when they, order the IPv6 and IPv4 address pair. They can take performance into consideration so that hopefully they will avoid, if IPv6 does not work, it can avoid it to avoid, performance disturbance. And the third one is this data. Like, if IPv6 is not used, then, provide the data so that to support problem identification and fixing. So these mechanisms are somewhat defined in the draft, but I recognize that we are the operation people, we are not the software developer. So we seek OS and software developer to, help refine the mechanism. We also have an incremental deployment approach because we recognize that if we want to get all three enhancements, it may take time. But this doesn't prevent you from start. So the key point is that we propose to divide an enterprise host into the early adopters and critical hosts. So the early adopters can be the friendly users who can tolerate certain, performance disturbance to experience IP problem, IPv6 problem, and help fix problem. And the critical one, maybe, for example, your executives or the servers, etc. That are you don't want to disturb. So the early adopters can be only partially, enhanced dual stack capable. It doesn't need to have all three. It may be, for example, with just a happy eyeball or the error reporting mechanism, maybe they can start. This way, and after you start, you monitor, for example, whether IPv6 is used, the IPv6 traffic, etc., the fallback rate, and you fix problem. So effectively, these change the existing IPv6 deployment model from a very, workload, front-heavy workload. You have to do all the, a lot of validation work before you switch on IPv6, and then also a big risky, into a gradual enablement, monitoring, and remediation processes. We believe that this will make it easier for small and medium enterprise to deploy IPv6. In the last slide, where I want to kind of like address some of the known concern. For example, one of the concern is that, lack of enterprise IPv6 adoption is mostly about lack of motivation. It's not about technology or difficulty. But we want to say that technology and difficulty does affect the motivation. So, the more difficult to do, usually, the less motivation people will have. And we also want to say that there are certain organizations, they already decided to deploy IPv6. So they do have the motivation. But because IPv6 deployment is quite difficult, as a result, they suffer and they decided to roll back. So enhance dual stack, if you can reduce difficulty, it will definitely, help in these cases. Another argument against it is that, well, it's mostly about manager support. Because it's not a technical issue, so EDS may not help. I would like to say that managers generally don't care. It's not that they have a bias against IPv6. It's just that they don't care. So if you say that, because I want to deploy IPv6, I need your support on this, on that, resources, then they will not support you because they don't care. But, if it's relatively easy for you to do, you ask for very little support or even, no support, then they may not block you either. So from this perspective, I think that it can still help. And the last one is like, oh, the network administrators, they just don't want to change because it's additional work for them, because, you know, they don't want to learn, you know, complex IPv6. But again, you know, if we can make it easy to learn, you know, easier, then I think that they may have some more motivation to change. And therefore, I think that overall, we believe that, you know, it's helpful. It's helpful despite the skepticism. And therefore, I hope we move from, you know, asking the why part to the how part. Like, you know, Eric, Philip are kind of like providing comments on the mechanism, certain mechanism. Yes, let's discuss the mechanisms. And again, you know, I ask people to review the draft, and especially if you have enterprise IPv6 deployment experience and software development experience, please help to define or refine the mechanism and possibly become co-author. Thank you.
Questions?
Philip Teasel. I have not a question, but a few comments here. And first, the draft is a mixed bag of things. And I think if one or two of these things should be successful, it would make sense, at least from my perspective, to fan them out and discuss them separately, because it's really an architecture of things that don't belong together. So let's start with the idea of changing the current socket API in a way that makes something of happy eyeballs light. I would might call myself as a happy eyeballs enthusiast, and as we spent a lot of time discussing all the details and what you could do wrong with happy eyeballs, that's definitely a very dangerous path on the one hand, and on the other hand, it's a path where the chance that actual operating system implementers would take up that idea of changing the behavior of get other info is practically zero. So I think that's damned to fail if you really ask about the operating systems vendors to do that. Even if you go into the classical network programming book, they tell you the pattern is use get other info and then loop over the results and fail back. So the solution that works in 90% of the case would be lowering the connection timeout, which would already work for badly breaking IPv6. In the next step, this still needs people fixing their code to do that loop, and you have a lot of documentation, especially in the Python world left, that just uses the first one of the reply of get other info. And I think now adding another hack on top of that is not a good way, and it breaks the assumptions of the API. So that's my primary concern about the technical solution. On the management side, I would say that things are even that more dire, because management big corporations is usually tasked for short-term gains. And let's be honest, we all know that IPv6 is a long-term game. It's an ultra marathon, and you won't finish that in a quarter. So there's a bias against IPv6, and we should rather focus on still explaining why it's worth the effort than to make it look less like what it is. Thank you.
Thank you, Philip. So I will just quickly say 3 points. The first point is that we are going to write a draft in 6 May to propose some update to RFC 6724. And because the OS company have already implemented 6724, if we have an update, I think that there's a chance that also get implemented. And this draft is also, talk about in happy working group. We'll see. Tom.
Thank you, Xipeng. Tom Hill from BT. I think we tried this at some point in the past, or I think Microsoft tried this in Windows, and it was not particularly helpful. They sort of did a test and remembered whether V6 worked or not, and then remembered that for a month before doing another test, and it was altogether a bad idea. So I'm not sure it was something we want to repeat, but perhaps more philosophically and more fundamentally, I think you're running a very significant risk here of reinforcing the ideology that IPv6 is hard and difficult, and it's not. But you have to be, as an organization, you have to have thought, I need to put the effort into this. We can't skip a few steps and it will work okay. So I don't think we want to reinforce that minimum effort that particularly enterprises will make. I don't think we want to encourage them to say, it's okay, we've checked the box, it's done, we can move on, we don't have to listen to people talking to us about this IPv6 thing again. So that's certainly more of a philosophical point, but I think the trouble is that if you reinforce how that this is hard, that will keep being the status quo in enterprises, and I think we need to change that rather than help.
Tom, I would say this. I think that GATT raised a similar concern. I really believe that for the people in this room, in V6OPS, maybe it's not so hard. But I think that for many of the enterprise network administrator, it's really hard. It's really hard. And I think that we have to acknowledge a problem. Every time we acknowledge a problem, maybe there is some concern. But still, I feel that if we do nothing, maybe it will take a very long time for the SMEs to adopt IPv6.
I have to stress something he's just said, and IPv6 is not that hard for the corporate network operators and for the application developers. It's not that hard. What is really, really hard is being brave enough to decide to get going.
That's still hard.
Once you're on your way and doing the stuff, I've had nobody in the company after that project that told me, oh gosh, it was harder than I anticipated. But I had hundreds of people telling me, oh shit, we discussed much longer about how hard it is than the stuff I actually needed to do.
Warren, are you?
Yeah, Warren Kumari, Google. I mean, making assertions that it's not hard and then looking at the amount of deployment numbers, something's not matching up here, right? Like
exactly.
Sure, but it might. Well, I can just comment that it's scary to get going, but once you get going, it's really easy. It's really easy for some set of people who've got a bunch of V6 knowledge, but there's a huge number of small enterprises where the people don't really know what they don't know yet. Especially if their network is currently really messy, and there are a lot of enterprises, especially small ones, where they don't even know how many servers they are. They don't really quite know where a router is, and any change for them is hard. Making this less hard. Jen's going to disagree with me.
Generally, go an enterprise operator who deployed V6. BGP is hard. ISPF is hard. VXLAN is hard, right? Cloud, I don't even want to think about it, right? People using what they need to use, and the reason enterprises don't do V6 is they perfectly happy without it. And no get other, whatever info changes will change that.
Warren Kumari again. I mean, yes, what Jen said, those things are hard, but a huge number of enterprises aren't doing those things because they're hard, right? Like, because they don't need them. They also, for many cases, they think they don't need this either. So we shouldn't make it, oh my God, it's really scary, but we should point out, these are the pitfalls you might fall into. Here's how not to fall into them.
Okay, thank you for your comments. Yes.
Hello, last minute addition to the agenda, because this time we broke our standard thing and we got 6 months before V6OPS. And when you have V6OPS on Friday, during the week, people come up with some crazy ideas over coffee. So remember Slack? Remember Slack Renum? And I think this group published RFC about all this renumbering issue and how especially home deployments suffer from renumbering. And now there is a follow-up draft in 6 months about how improve Slack renumbering events by tweaking timers. So that draft is actually still in the 6 month last call, because the authors and reviewers are discussing for hours about what to do about network and devices dropping multicasts and how many multicast arrays in a given period of time is enough and how short this period of time should be, and is it going to be raised to the bottom when network sends more multicasts and device drops more multicast and so on. And as a 6 month chair, I wanted this draft to progress. So I was like, for how long we're gonna discuss this, and can we add another like sticky tape or band-aid on top of this? So if the main problem is that multicast arrays are dropped, and the problem we are trying to solve is renumbering when a router wants to propagate some changes in the information, can we just send those arrays as unicast? I don't know if it's a good idea or not, and it's definitely not a silver bullet which is supposed to solve every single problem. I was thinking about it more like there's no Swiss cheese stuff when you put another layer hoping that holes do not align. So I posted 00 very quickly, and that one pager was just saying, okay, just look in your neighbor discovery table, look at all link local neighbors which are reachable or stale, and just send unicast array with configuration change information which you want to propagate quickly. Then I think few people pointed out that we actually can just convert L3 multicast to all hosts to Ethernet unicasts, doing more or less the same logic, right? Obviously, enterprise networks often actually do it on the Wi-Fi level, right? You can configure your Wi-Fi controller to do multicast to unicast conversion, and it's supposed to help. So I don't know basically what's the right approach here, or maybe we can again combine different things. Based on the review, obviously, there are some fine details we need to tune in the draft. For example, obviously, do not send everything together and spread them. Do something about flapping links. And again, enterprise networks probably do not need this because your Wi-Fi stuff does this. It's more about like small CPE stuff, small networks. And I actually think this network does not do the conversion, at least based on what I see in the packet capture. So they've been I see Andrew is trying to go to the queue, but yes, we did discuss it on the list. Can we just send array always as unicast? The problem is, right, if you're talking about layer 3 unicast, it's a problem because if you are in your router, you don't know who your neighbors are, right? So you definitely need to keep L3 multicast to all hosts. Maybe the right solution, as we discussed, just to fix Wi-Fi thing and just always force APs to convert multicast to unicast to all neighbors, which actually means we, instead of writing all of this, we need to write one pager and go to Wi-Fi people, right, and sort this. I am like open to suggestions. Maybe we can do multiple things in the same time and so on. So, questions?
Andy Yurchenko, in the business of converting arrays to unicasts for 10 years. I think the first, the concern is maybe not so big because the host, when it comes up, normally sends router solicitation, and a lot of those can be already unicast. But there is another thing that I kind of didn't see too much in the draft, which is if we do send it to IPv6 unicast, then we might inadvertently trigger the NUD. And if we are doing a flash change, that there probably should be more text.
02 actually talks about this, and that's the reason why second option is actually better. When you still have L3 multicast, send as L2 unicast, it would avoid all of this, and apparently, yes, there are other benefits. Again, this draft 02 actually talks about that stuff. But again, right, about new host, no, it's not about new host coming, it's about you reboot the router, it gets a new prefix from PD, right? It would not solve in this case, because the new router comes up, it has no idea what's going on, or you plug in your router. The good thing is actually that if we plug in a new router, in addition to existing stuff, your host can use the old stuff. If all routers disappear and only new stuff coming up, your host probably lost network connectivity, and then they will start doing something about that. Like devices like Android will just follow the network and reconnect, and so on. Again, it's not a silver bullet. It's not going to solve the problem. I think about it more like an optimization, which, based on what Slack Renam talks about, seem to be a problem. Right? And how we can make it more reliable. Again, maybe we just need to talk to Wi-Fi people and tell, please always convert multicast to unicast. I don't know why it's not a default. I have no idea. Is it hard to do? Is it not recommended? Other corner cases? Why do Wi-Fi access points don't do it all the time?
Yeah, I mean, to add one more comment about the optimization, the optimizations that are kind of corner cases, which this would be, tend to be broken. So that's where I would say it would be interesting to see whether we can make maybe all arrays follow this scheme, because I think there's no fundamental problem with it.
Hey, Jen, just one point here, because you are proposing to do this only when something significant changes in the array, like renumbering of the network. That also means that, by definition, if you are renumbering network, all running sessions will break because the network is renumbering. Like so it's already very disruptive event.
It's not necessary case. I might add the new prefix. I might change timers. It might be. I do have a feature request for certain network vendors. So when I do commit on configuration impacting array, I want a new array to be scheduled immediately and sent. It does not necessarily I remove the old prefix and new one. It could be anything which changes content of the array. Well, it doesn't mean you necessarily break the new stuff. Maybe old stuff still works, right? But I want to renumber, and I don't want to wait for like hours and hours for old sessions to disappear.
Well, that was basically my point. So I'm thinking if you are like, if the point here is to make sure that everybody on the network hears the new array because there are important updates in it, then I think it's actually a reasonable compromise to send even hundreds of unicast packets on the network to make because the network is probably being disrupted anyway.
And like, to be honest, it means one packet per client, right?
Yeah.
Is it like a big, if your router cannot send one packet per client, I think we have a bigger problem here.
Eric Vink, Cisco. So good job, go for it. Same comment as Andrew. You may want to think as well to send a multicast array first.
Like draft currently saying, do this in addition to whatever you're doing. It does not specify the order because I don't know if it's beneficial or not to over-specify here. And if there are preferences and reasons to do that, I'm happy to. If not, I'm trying to be as like less. I'm trying to be a least restrictive.
David Lamparter, I already made my comments on list. You did ask whether it's worth doing this versus going to try to fix 802.11. I think that's not the question. I think at this point we just do everything and we see what works. That's what will somehow get this to.
So okay, so do you like me to go to to talk to Liza, or are you going to do that? Or we can do it together?
Yeah, let's talk about it afterwards.
Tim Winters, QA Cafe. So a couple things here. I generally like exploring this idea. I think we should be real careful with the scope. The only other thing I'm going to say here is CPEs traditionally keep the RA stuff far, far away from the ND stuff. So it's going to be really hard to pair those two together and have it look up all the caches and send it out. I mean, it's doable, but it's not a typical flow for most home gateways.
Okay, that's a valuable feedback. Yeah, again, yes, it's thank you. Yeah, I would like to hear from implementers because Lorenzo pointed out array DVD has a similar thing, but you need to specify all neighbors in the config, and then it never sends a multicast. I don't know if you can kind of mix and match those modes.
I think there's some things to explore here. I think we should explore them.
But Tim, you still think it's useful, right? Yeah. So it's not a bad idea.
I'm not going to go that. I think there's some things to think about with RA guard. I think in general we should talk about this and we should continue to work on it. So I don't think it's a bad idea, no.
Lorenzo Colletti, obviously we do need to solve this problem. Unfortunately, I actually think this is not the right solution. Unfortunately, because it's easy. And it seems to make sense, but I think like one issue that we have is for something like Snack, right? You don't have the neighbors in your neighbor table, right? So you have all of these issues, and you're putting all of these workarounds. I mean, I think if we think we can influence, so the other thing is that you've got all of these deployments. Like I have a home router, and I have these mesh Wi-Fi boxes. They're not the ones sending the arrays. So I think if we want to do something, we Android are going to try to fix some of the hosts, but it'll take years. But I think if we want to do something, we should basically go to 802.11 and say, look, we give up. For these packets, just send them unicast because no, but even DMS, right? DMS is oh, now I have to implement this thing, and then everything's going to be buggy, and I have these state overflows, and then sometimes it's not going to work, and I just think we should just say, look, 802.11, these are critical packets, just always send them unicast, because the nice thing is that the AP does have the list of MAC addresses. So I think we're better off, unfortunately, just writing a document that says that.
Okay, so because my knowledge of Wi-Fi is much more limited than I'd like it to be, is there any disadvantages of doing that conversion? Why it's not a default? Because nobody has asked for it, or because there is issues with it? That I don't know, and I don't know if people could tell me.
Because it doesn't break IPv4?
So nobody asked for it. Okay, yeah, that's fine. That's a good answer. Yeah, if it's the case.
Oh, and also, it seems to work well enough that no one thinks to fix it, and it's. Yeah. Even now, if the timers are right, it mostly works, right?
Tim Chow. So I think Lorenzo's answer is the practical, pragmatic thing. I would just point out, though, that if you want to tell a host over unicast about changes to the network and the network it's in, there's always DHCP V6 reconfigure.
Who are you again? Anyone has a pen? I write it down. Okay. Thank you. Okay, well, again, it's a 6-man document, so next time we'll talk about it in 6-man. Thank you.
Good morning, everyone. My name is Le Guy from Tsinghua University. Today, I will talk about observation on the how packet carry IPv6 and external header in the internet, and where and why they are failed. By the way of background, IPv6 external header sits between the basic layer and up layer protocols. And an embedding key feature will keep their basic higher simply. They are widely used for mobility, security, and routing. While their handling also introduce security risk handling can be like traffic pass-by filters or correct denial of service vectors. This gap between intended functionality and the real-world handling motivated this study. Two questions requirement open. First, how reliable different extension headers travels real world, and what caused the package to drop. Second, whenever extension headers can be used to get past firewall rules. Extension work report drops rates, but not the underlying mechanic or security implications. The mathematics combine two approach. Path travel measurements send a prober and record the last responding nodes, indicate where packets are dropped. Comparative analysis contrasts under probers with extension header probers to infer where filtering occur and whatever extension header pass by in the filter. The measurements are carried out with low travel, a large-scale mathematic measurement tools across the internet. For the step, 11 common extension header types are tasks, and the target set covers 7.3 million / 48 perfect across the near 24,000 AS and 17 industrial sectors. All measurements orient from the single white points in an educational network in Beijing, giving broad coverage of global IPv6 paths. Unreachable, the destination operation and the automated fragment headers now reach the destination close to standard TCP and UDP traffic, where fragments and route headers remain more heavy filtered. The near part of some extension header favor deploying extension header basic technologies, but the same property lets malicious extension header traffic travels the network, although almost as well as normal package. Broken down by industrial to construction from policy, traffic constructions, media, manufacturing, fix permissive policies. So some extension header even exceed the baseline reachable, will reach the exports. Governments enforce a strict TCP filter for nearly all extension headers, which is safer but constructor IPv6 evolution. Healthcare by contract is protocol neutral with minimum filtering. On the security side, if extension header pass filters, they may be used to bypass firewalls, map handler network, or reach protect service. A partial bypass is denied as a destination that block standard probers, but accept extension header probe index extension header let traffic slip past the firewall rules. The scale is significant. Roughly 5,000 AS exhibits potential bypass significance. The effect is more pronounced for TCP and UDP rather than the ICMP, and it's been every industrial sector exempt. Indicate a widespread rather than isolated issue. It can be speculated that there are several contribution factors. Some may be contributes to implementary bugs in how sprite extension headers. Others may stem from misconfiguration, pattern reputation, and in the controlled tasks. In addition, IPsec policy may be configured to permissively, and newer extension header types are frequently left unhandled and forward without inspection. One concerned case is related to the pattern. In an observation campus network, 2-edge best by 4, we can see the 2-edge router extension, classical extension headers fails. The firework inspects only the first layer header. And if it isn't not TCP or UDP, the package is permitted. A TCP SSH connecting the inside extension header therefore passed without inspection of the inner payload. We offer some suggestion. First, the firewall should inspect the full extension header chain before applies ACLS. Through deep inspect clear DOS risks. Selective filtering can limit the tabs, the length, and the number of extension headers. A layer approach apply a deep inspections to permitted extension headers. Authorize blocking, stop, evasion, and but also hand out IPv6 evolution. So the goal is evasions without fully closing extension header deployment. Thank you for your patience.
Eric Ving, no special hat except that I spent multiple times doing similar stuff, pretty much like the guy behind me, and I will talk about you this time. So first thing, normally when you are in the room, you need to scan the QR code to be in the list of participants, and I was unable to find you. That's a detail. On the slide 2, you say that firewall cannot process packets with extension headers. All the firewalls I know for 5 or 7 years now can simply skip. It's different from some high-speed router, high-speed switch for sure. You may want to consider, if you continue your research, to compare it with existing research that has been done by several people in this room, where you use another suggestions for improvement. I mean, the single vantage point located in single geography is pretty limiting. You should at least one vantage point per continent. It will help a lot to get much more accurate result and useful result. May also suggest that using SSH and SNMP that are typically management protocol that could be blocked on purpose by some firewall, right? So using those for the probing is probably not the correct. It introduces a bias. And lastly, the guy behind me and myself, we wrote RSC 9511, which basically contains some, when you do probing like this, if somebody detects it, they can relate it's not a DOS, but it's basically a scientific research. Did you use it?
Yes.
Okay, perfect then. Thank you.
Thank you for your comments. I will to add the vantage points, and I will to compare with current research.
Justin Yearman, 6 Wind. So I concur with Eric. All the remarks were good. One more comment. I think here you are using the small size for the extension headers, right? So what you are actually measuring here is the best case. And this is why you have some good results, let's say. So I suspect that if you increase the size of specific extension headers, you would see the results decreasing, right?
Okay.
Okay. Thank you.
Hello, can you hear me?
Yes.
Hello. Good morning, everyone. This is Chen Hao from China Telecom. On behalf of our authors present this individual draft, considering solutions of IPv6 only deployment in 5G mobile networks. Next slide. First of all, is the document core objective review. This draft is to bridge the gap between standards and deployments, and also this is the value of this draft. We did a research of relevant RFCs, RFC 7445 analyzes some failure cases in IPv6 roaming scenarios, while RFC 64 and 59 provides an overview of IPv6 in the 3GPP Overload packet system. So there don't have a dedicated document that addresses 5G IPv6 only deployment from an operator's perspective. And also, this draft is to address real-world deployment challenges. How does the network know if UE supports IP only, and how to ensure IPv6 service continuity in roaming scenarios, and gradually roll out without impacting production traffic. And then the last drive the industry consensus. Next slide. Now is the third 03 version. What we have updated, first the title, we remove the word gradual to make it more general. And the target audience, we added 5G basic concepts related to IP for broader community. For deployment approaches, we now focusing on PCO-based and RA-based, and added a DNN isolation for testing. So for operation consideration, we add a new section 6 to talk about the organizational challenges, Net6 for performance and IPv4 OR services. For 5G concepts, we add a new section 3. It talks about 5G concepts, DNN, PDO, session, and roaming modes. Next slide. Here we bring up two deployment solutions for further discussion. As we know, PCO is 3GPP specific control plane signaling. In PCO-based solution, UE signals select capability while PCO, but there is no IETF or 3GPP standards to define the parameters or procedures. Is enterprise specific. And for RA-based solution is what we want to advertise prefix say for such information where RA. So, and we can reuse some existing tools. Should note that we don't talk about a basic protocol about RA or PCO based solution. This draft just document the information what we have about 5G IPv6 only deployment. This topic is for open discussion. I think here we have some work, maybe have some work to do. For PCO-based solution part, we maybe need to define the basic parameter and the procedures. And if we think the RA-based solution is the good direction, and we need to define some corresponding mechanisms. Next slide. here, why we recommend the R-based approach. My point is that IP-related matters should be handled at the IP layer, and this will help us simplify deployment and implementation, avoid the involving other domains, and ultimately makes deployment easier. Here, I also list some advantages, including the access agnostic. So we will have a unified framework works across the cellular or Wi-Fi fixed satellite, and other advantages maybe the control plane decode, no 3BB core signaling dependence. SMF doesn't need to know UE capability. Dynamic updates, Net64 prefix change propagated will RA. There is no PDO sections re-establishment needed. And also by including fit sharing and observability. Next slide. I can't see. There are some questions we received and our responses. I think this will help make the document clearly. First, the IPv6 only is actually referring to 464 XLAT, IPv6 only with IPv4 as a service. And CLAT like functionality can be provided in other ways. And we will add a note in the terminology section. Not all UE supports CLAT could be clarified further, including vendor policy, firmware per 5G devices, etc. So we will expand the explanation to cover the various factors, including vendor policy choices, firmware, and device generation. Section 5.1 says no standard defines PCO-based parameters. Is this no standard, or what to do about it? Just mentioned in the previous slide, so I don't repeat it. Mr. Tethering and /64 prefix sharing explanation, and we will add a subsection, add a text on this. Next slide. So thanks valuable inputs from V6OPS, special to Jordan Matt. We think this draft is the draft target is informational, and we welcome more discussions on 5G IP-only deployment topics. I think that the structure of the draft is good enough, maybe good, and we hope can be adopted as a worker group draft and serve as a useful reference. Thank you.
Jordi Palet. I think this document is taking a good shape. I think we should adopt as a working group item. It's a very important work. I think also we need to work with the liaison with 3GPP to either do a POC profile for NAT64 or the array or bot. I am not sure how hard that will be with 3GPP, but I think it's something that we need to sort out because it's one of the problems that we have with deployment of IPv6 in mobile operators. It looks they are relying on RFC 7050, but in an incomplete way because they forget that it was updated by RFC 8880. So it's not really working as expected.
Jerlinkova, yeah, I am glad to see that some mobile operators might be interested in prefix 4. And yes, and I guess 3GPP and more importantly, I guess the equipment vendors here need to be informed. I suspect because like we already have array options, so all I think it needs to be done is for equipment which sends array to support this, and I guess it should come from the customers, right? So yeah, please ask them, and I guess we'll start, and probably eventually mobile operators will move in that direction.
Okay, thank you.
All right. Well, we ended with 1 minute to spare. For the as time permits drafts, please take the discussions to the mailing list so we can continue talking about those. And yeah, do you have any closing comments? If not, this concludes V6OPS for IETF 126. Thank you.
Thank you for your participation.
So basically, we have almost exclusively and what we did was we just wrote a script that the client that we have, it'll let you run arbitrary scripts on up and down. So we just basically there's at least one. I think there's actually two. Put it down. Wow. Leave it assigns it to. No, it assigns it to one. Yeah, that mostly solves the problem. Now, yes. We've recently switched to we moved from like an open source open